5, 6 beats per minute for a whole 5-minute period. So that's really extraordinary if you think about comparing that to an exercising human or any animal exercising on the surface of the earth, where you have this characteristic exercise response. Your heart rate increases to get more oxygen and blood flow to all of the exercising tissues and muscles. So these animals are down there, they're also exercising. They're swimming around, they're catching fish, they're foraging, and they're doing that while lowering their heart rate. So it's this really unique dive response. So for my postdoctoral research project, I kind of went to a different extreme. I became very interested in the bar-headed goose, which is the species of goose that migrates twice a year over the tallest mountains on the planet, so over the Himalayas. If somebody's thinking about climbing Everest, then they go weeks in advance, they go to base camp, they allow themselves to acclimate, their physiological processes catch up a little bit, get some more red blood cells on board. These birds are doing that crossing in 7 to 8 hours. They need far more oxygen in order to support themselves while they're flying than they would if they were walking or down here at sea level. But they're doing that in an environment that has an oxygen limitation. So how are they doing that? We decided to try and look at this problem by training bar-headed geese to fly in a wind tunnel. And in order to make sure that the birds would be comfortable with me and my team, we imprinted the animals. It's particularly strong in waterfowl. So the first thing that a duck or a goose sees after they hatch, they look at as their parental figure, and they imprint. So I got some eggs and I had the birds imprint on me. So I was there from the time that they hatched. They would be hatching in my hands, coming out of the egg, and I was the first thing they saw. So they thought that I was their mom, and I was a modern day mother goose. I had 12 goslings that were following me around everywhere I went. They look to you for everything. You're going on walks, you're cuddling with them, taking naps. It was really an extraordinary experience to have that connection with an animal. And they grow quite quickly. Within a few months, they had fully grown wings. And so we brought the birds back to the University of British Columbia and started training them to fly in the wind tunnel. And we outfitted them with physiological recorders, little backpack recorders to measure heart rate and then again oxygen level. And then they also were outfitted with a mask, so a really lightweight mask that we made out of a dental mold material. And that allowed us to collect the air that they exhaled. And then through that mask, we could also change the amount of oxygen that they were breathing in. So there was a tube where we would flow nitrogen into the mask and basically decrease the overall oxygen level so that we could simulate altitude. So we were flying these birds at about a half to a third of the amount of oxygen that we have at sea level. A third of the amount of oxygen is equivalent to higher than the summit of Mount Everest, so higher than that tallest peak. And interestingly, as we predicted, the birds could still fly. And it really isn't just one adaptation. There is really a host of adaptations all the way through what we call the oxygen transport cascade. So everything from getting the oxygen from the air into their lungs, getting it into their blood, getting it down to the individual cells and into the mitochondria, which are the powerhouses of the cells. So they really have adaptations at every step of the way.